guys. So today we're going to look at something called Cramer's rule. Cramer's rule is a way for us to use matrices to solve systems of equations. So to start, we need to learn about something called a determinant. So a determinant is something we're going to use within Cramer's rule. It's also something we're going to use next class when we look at inverses. So the determinant is actually just a single value that we calculate from a matrix. Specifically, we find it for square matrices. So we're only able to find them from 2x2s, 3x3s, 4x4s. It has to be a square matrix for it to have a determinant. So that determinant is a value that helps us for Cramer's rule for solving systems. It also helps us when we get to inverses. So the notation for determinant, you'll see it a couple ways. You may just see DET, you may see DET and then the letter of the matrix, or what we'll probably see the most often is just those straight bars that look basically like absolute value. And in terms of matrices, that actually just means determinant. So for example 1, we're going to go ahead and find the determinant of that matrix. So if you look over here, you'll see this is basically the pattern that we do. We take this diagonal that's going down, we multiply those numbers together, and then we subtract this diagonal that's going the opposite way. All right, and that's going to be a similar pattern we use later. So I would do 1 times 8 minus 4 times 5. So that's 8 minus 20, which is negative 12. So the determinant of A is negative 12. All right, so let's look at B. Again, the determinant of B would be negative 6 minus negative 28, which is just 22. So again, these determinants are going to work out just to be a single value. So the determinant is something we're going to use within Cramer's rule, and Cramer's rule is something we can use to solve systems of equations. In order to use Cramer's rule, we're going to make a few matrices and find a few determinants, but in order to do that, we need to look at these equations when they're in standard form. Now, this doesn't have to be exact standard form like you learned in Algebra 1. It'll be in the same pattern where it's ax plus by equals c, but that a value, it's okay if it's not an integer, and it's okay if it's not positive, but it needs to be in that order. So let's look at Cramer's rule. So what we're going to do with Cramer's rule is we're going to come up with 3 matrices. We're going to start with the coefficient matrix. And what that means is we're going to take the coefficients of the x values and the coefficients of the y's, and we're going to create a matrix, a 2x2, with those coefficients. Then we're going to create another matrix using, replacing basically those x coefficients. So I'm going to take those answers and those constants that are on the other side, and I'm going to replace the column that had the x values. Then I'm going to create one more matrix where I'm going to take those constants and I'm going to replace the y values instead. Once we have those matrices, we're going to find the determinant of each one of them. And then what we'll do, that determinant, the determinant of the x matrix divided by the determinant of the coefficient matrix is going to give us the x coordinate. The determinant of the y matrix divided by the determinant of the coefficient will give us the y coordinate. So let's look at an example here. All right, the first thing I need to do is I need to come up with my coefficient matrix. So the matrix of my coefficients, it's already in standard form, so 2, 3, 1, and negative 2. So the first thing I need to do is find that determinant. So that determinant is negative 4 minus 3, which is negative 7. So now I'm going to find my determinant of the x matrix. So I'm going to take that same matrix, but I'm going to replace that 2, 3 column, which is the x coefficients, and I'm going to replace it with that answer, the equal, the numbers on the other side of the equal. So 10, 8, 1, negative 2. Now we'll find the determinant, negative 20 minus 8, negative 28. And then the last one, I'm going to do the determinant of the y matrix. So again, I take that original coefficient matrix, but this time I'm going to replace the y column with those constants. So this matrix is going to be 2, 3, 10, 8. So 16 minus 30 is negative 14. So once I find those values, the x coordinate is going to be negative 28 divided by negative 7. The y coordinate is negative 14 divided by negative 7, which is just 2. All right, so let's look at another example. So again, we need to rewrite this equation in standard form. So I'm going to start by rewriting it. 3x minus 2y equals negative 5. And then 9x minus 6y equals negative 15. And you may notice something about these equations before we get to Cramer's rule, but I want to at least still work it out so we can talk about it. So my D matrix, I would do 3, 9, negative 2, and negative 6, which would be negative 18 minus negative 18, which is 0. So if the determinant of the coefficient matrix is 0, that tells us a couple things. First of all, when I evaluate these things, I'm going to be dividing by 0, which I can't do. So there's two possibilities here. This is either infinite solutions or no solutions. To find out which one, let's go ahead and find the determinant of x. If the determinant of that x matrix or the determinant of that y matrix gives us actually a number and not 0, then it's just going to be no solution, because a number divided by 0 does not exist. But if we get 0 over 0, that's actually going to be infinite solutions. So let's go ahead and find that x matrix. So I'll replace the 3 and the negative 9. And that's going to be 30 minus 30, which is 0. So since it's 0 over 0, this one is going to have infinite solutions. Now you could probably tell once you rewrote it in standard form that those were the same equation. But again, it's good to see what that actually means about the determinants. All right, so now we're going to look at the determinant of a 3 by 3. So it's going to be very similar, but we need to do a couple extra steps. So what we'll do, we'll take our 3 by 3 matrix, but we need to extend it so that we can get these diagonals. So what I'm going to do to extend it is I'm going to take the first column and the second column, and I'm going to rewrite them after the original matrix. So that's going to give us this big grid. And now I'm going to find diagonals just like I did with my other determinant, except this time I need 3 diagonals. So I'm going to do A times B times C, there, there, and there. And I would find each of those diagonals by multiplying them just like we did on the other. Then I'm going to find the diagonals that are going up as well. And just like we did with the 2 by 2 determinant, I'm going to add the ones that went this direction. I'm going to subtract the determinants that went that direction. All right, so let's go ahead and try an example. So I'm going to take this matrix, and I'm going to start by rewriting and extending. So 2, 5, 1, 4, 2, 4. So now I'm going to find my diagonals. So I'm going to have one diagonal this way, and this way. Multiply those values. So that's 32, 12, and 20. Then I'm going to do my diagonals go in the opposite direction. Multiply those values. So that's 2, 24, and 160. I add the numbers that were on those down diagonals, just like I did for the 2 by 2, and I subtract the ones that were going up, again, just like the 2 by 2. And then when I simplify this, I'll get my determinant, which should give me a negative 122. All right, so with a 3 by 3 determinant, it takes a little bit longer. Cramer's rule will still work with these 3 by 3s. But because it's going to take a little bit more time to find all these determinants, we're actually going to go ahead and look and see how we can use the calculator to find these determinants to help us do this a little bit faster. All right, so we're going to look at a couple different ways to use matrices on the calculator. So your first option, there's 3 different places really to find matrices on your calculator. The first one, from your main screen, when everything's cleared out, you'll see this MAT with that arrow. That is a menu that allows you to store matrices. So if you're going to use a matrix more than one time, that's a good place to go because you can continue to call that same matrix over and over. So we'll start there. So I'm going to do that MAT button, and this allows me to, let me go ahead and delete them so you can see what it looks like from the start. All right, this gives me a couple different matrices that I can enter. So let's start with just matrix A. I can enter the dimensions for matrix A, so I'll make it a 2 by 2. And then I can enter whatever values I want to enter in here. And once my matrix is entered, then I can go ahead and click exit, and I can go back to my main screen. So now, if I want to do an operation with that matrix, there's a couple ways I can get there. One thing you'll notice, there's a button over above the 2. You'll see where it says MAT. So in order to use a matrix, I need two things. It needs to be MAT and then the letter of the matrix. So I can put this in my calculator by doing Shift 2. That gets MAT. And then I can do alpha, letter A. Now I can do whatever operation I want to do with matrix A. So if I want to do matrix A plus matrix A, I can do that. If I want to do 2 times matrix A as a scalar, I can do that. All right, and then there's other operations that I can do within that matrix. If you have more than one matrix that's entered, you could do matrix A times matrix B. Like let's say you have 2 matrices that are entered there. I don't, so it would give me an error, but that's what you can do. So in order to do those operations, again, you just need the MAT and then the letter of the matrix. Now, there's a couple other places you can find this matrix option. Now, let's say instead you want to actually enter the matrix onto the screen that's here. You can do that as well. So the way you'll do that is using this math function. So if you look where that F4 is, so right here, where it says math, okay, that F4, that's going to pull up. You'll notice it says MAT again. So we have another matrix menu in there. All right, so from there, this time you'll see it gives you 2 by 2, 3 by 3, and m by n. So this is going to allow you to enter a matrix directly onto this screen. So if I did 2 by 2, this gives me a matrix on my screen that I could then enter my values for. And then from here, you can do whatever operations you want. So if I wanted to do this, if I want to do 2 times that matrix, or if I want to take that matrix and I want to multiply it by another matrix, I could say times m by n, let's say multiply times a 2 by 3. And that'll give me a 2 by 3 matrix that's on my screen and I can enter my values for. All right, so again, similar to if I just put those on that menu, I could still call that function, but this allows me just to enter the numbers directly. So this is kind of helpful if you're only really using the matrix one time. This is also helpful for Cramer's rule because you can quickly go up and just edit that row of numbers. So there's an operation right there for you. All right, so now let's talk about actually finding the determinant. So far we've just done our basic algebraic operations. So all of the different things you can do with matrices are actually hidden in another menu. All right, so let's take a 2 by 2. Let's say I want to find the determinant of it. So what I'll do is I'm going to go on my keyboard. The last place to find matrices is where it says option. Okay, so if you go to option, and then again, now your menu will change. You'll see at the top it says MAT. That's again going to be another matrix menu. And this is going to be where we have all the different operations for matrices. So we'll come back to this again on Friday and again next week. But specifically for today, if I'm doing the determinant, this is another place, again, if I want to enter matrix A, this is another place to find that MAT as an option. But let's go ahead and do determinant. So I'll select determinant. And if I want to do the determinant of the matrix I've already entered, I can do determinant of matrix A. And that will give me the value of the one that I saved. Okay, if I want to find the determinant of a matrix I haven't added, for example, my 3 by 3, I'm going to exit, and I'm going to go back to math. I'm going to go to matrix, and I'm going to enter my 3 by 3 matrix. And I can enter all those values, and then it'll give me the value of that determinant. And there's my determinant. All right, so that's just a couple places that you can find your matrices. Now, if you ever forget how to get to determinant or how to get to something else, kind of another option on these Casios, every function that you need, if you go to Shift and then 4, where it says catalog, that catalog is a big list of every function that is on that calculator. So if you can't find it, without fail, at least it's going to be in that catalog. So for example, if you can't find determinant, you can scroll down to the D's, ABS, that's your absolute value. So if I go to alpha and D, that'll take me down to the D's, and I'll see there's determinant. So in case you ever forget where it is, you can always go to the catalog if you need to. But again, this is helpful having it in the screen here for Cramer's rule, because now let's say that was my coefficient matrix. I could just scroll up and I could just change just that one line to be those constants to get my new determinant without having to go all the way back into the other function and rewrite your matrix. All right, so let's go back to our example that we had. All right, so we're going to go ahead and set this up for Cramer's rule. So what I'm going to do is I'm going to start by writing my coefficient matrix. So what you'll notice here, this is in standard form, but you'll notice it's missing some variables. So if it's missing some variables, something that we need to do is we need to fill in zeros as placeholders for the ones that aren't on there. So I've got 1/2. There are no y's, so I need to fill in a 0, and then 1z. There are not any x's, so I need to fill in a 0, 1, -1/3, and then I've got 1, -3/2, and 0 because there are no z's. So that is my coefficient matrix. So I'm going to evaluate that determinant. I'm just going to go ahead and use a calculator, and I'll find that that determinant is -5/4 or -1.25. So now I can go ahead and evaluate x. So x is the determinant of the x matrix over the determinant of D, just like it was for the 2x2. So this is going to be the determinant of that same matrix, but replacing that first column. All over a -1.25. And that'll give you your value for x. Same thing with y. You would get that y matrix. So I would replace that middle column with those constants on the other side. And that would give me my y value. And then to get my z, I would evaluate that last determinant. And replace that last column with those values. Evaluate that determinant and divide by that -1.25. And when we finish this up, we'll end up with x equals -2, y equals 4, and z equals -3. All right, so that's it for determinants and Cramer's rule. We'll use determinants again next class when we get to inverses, and we'll look at a couple other ways that we can solve systems using matrices.